Today I just bring a fresh new project to all of you guys. This is a project we just done, just fresh start in Guilin. It's an airport, new airport terminal, and fully by the structural steel. So the whole structural steel framework, just like a waving form, and made by a lot of the cantilever chars, etc. And so it's about 100,000 ton, and we just keep going for that. Firstly, this project is just like some kind of the mix with the concrete. So the whole foundation and the slab is done by the traditional method. But just like all you guys understand, all other component is made by the structural steel. And our client just requests us, he said, I want a beam start from the LOD 250, but keep continue to 500. And that is quite challenging because all you guys know the connection design will be a difficult part to handle about that. So I try the Tekla, and I try the SolidWorks, and I try the advanced steel. I have to find a way to get things done. So I'm going to show for this project, I select the workflow is from the Revit to advanced steel, and then to the Navisworks, and then finally come up the BIM 360 for the coordination. We did not select the robot, but we're using the methods and the PKPM, which is quite significantly using in China to do the analyst. Okay, the difficulty is they have just like a wave, a form in the whole roving. And they do not really have a column. We call that supporting, but this column is just made by the playwork. So the first difficulty is if you make the steel by the playwork, then you really hard to using the Tekla to model it because it's made by piece and piece. So you can see when we do the mock-up, and all this steel is just like a triangle shape. The first time we try is like this one. It's very huge compared to the people inside. So it's just like using the playwork to make, this is a cross section, and in all the cross section we have the stiffener, and all made by the playwork and weld together. And we have to model it. We have to model it from the beginning with the connection design, and then keep going for the fabrication. Because we don't have the time to say we do the modeling double times. So, yeah, that's what we've done. And also for the installation, the structural steel is not like the concrete things. We have to achieve a really high accuracy. And we do a lot of simulation, but this simulation is done by the 3D Max at the beginning. And then later on, I think in the next stage, maybe in the mid of the 2017, we will do it in the Fuser or other things. And when we try to do the installation, we find a lot of the detail is missing by the original design. The designer did not really think about that or what is the procedure you are going to use when you're doing the temporary work. So which means we don't have the detail for the connection because they think that everything is just done certainly. So we have proposed a lot of things, and then a lot of the designs coming back, and we need to do the connection. Once we've done the connection, trial and error backward. So that is the key difficulty for the structural steel. And we select, and finally, we're using the advanced steel. Not fresh new software, but it's not that very common at this moment. And the good thing is, it's just like a CAD. Actually, it's just like a CAD. It's plug-in, a complete plug-in in the CAD. So we from the Revit background. But when we're using that, we don't really feel the strange because you can using the layout control to select the object to do the object management. So it's quite user friendly. Yep. This short video is showing It's just like a CAD, but actually it's advanced still. They have a lot of plug-in function for that, especially the UCS. When we're using the UCS, we can just pick up the line. We can pick up the line showing in the 3D drawing and come up with our object. So actually, I can't tell what is the BIM and the CAD, because I insert a CAD drawing and then you turn up for the object. You can put all the parameters inside. But you can see, even for the 3D, even we're using the CAD platform, when we facing the irregular shape, we select a dynamo. Previously, I tried the grasshopper, and but grasshopper is more friendly with the Tekla. If I were using the advanced steel, I think dynamo is more combined with that. And using that, we done from the first line. We're using the dynamo to get a starting point. And using that in starting point, we can build up the shape. We just skip for the, yeah. So your guys can see, if you want to build a column, this column actually is from the small beginning and then become more larger. And we create a reference line, reference point, and then the line and point just come up, become a face. And that is come up, become the plate. So actually, why we're using the dynamo is because all these truss, you can call the column, you can call the truss, is actually made by plate. And all triangle plate together, weld together to form a big column. And we need to fabricate it using the NC machine. So we've done that, but dynamo really have a little bit problem when you really transform it, because the layer, they did not have really much allowance function, just like a grasshopper. Maybe in the future it will get better. Once we done that in the Revit, because at that moment I don't know we have a plugin for the advanced steel. Now we have a plugin for the advanced steel. But when I done the job, I actually built that in Revit using Dynamo to the Revit, and then using the Revit to export that to the advanced steel. But at this moment, if I done again, I actually can directly do it in Dynamo and then transfer to the advanced steel. And yep, this is when we're done. So actually, the designer, the architect, and the engineer, what they're giving us is just a CAD drawing, all right, with SketchUp. The SketchUp is showing us the roughly idea and give us some certain RL. And when I get the job, I need to think about that. If I really using the SketchUp to keep going to do that, or using other software, I facing a problem is my client say, I want to fabricate it. And the connection, if you're using the IFC to export that, the connection will be not magnetic. It's not parametric. It's just like a solid shape. And I don't want a solid shape because it keeps changing. So what happened is, actually, in past 10 years, we're using a lot of the job done by the structural steel, the detailer, and the structural engineer actually is separating. They are not collaborate together because the contract things. And at this moment, we try to say, for example, say this is actually like a holding down bowl, but it's not a holding down bowl. It's like the foot for the column. It all made by the play work. At this moment, we can directly using the BIM model to LD450 to do the automatic drawing, and then put the dimensioning on, and then put the DXF and NC file. So we fulfill the requirement. And once you've done the model, all the remaining things is just like a CAD. We just do the CAD drawing. So actually, it's not that hard to learn, because a lot of people know how to use the CAD drawing to do the dimension and present the drawing, especially the worker in the workshop. So that's one thing I want to show. And the shortcut list is quite good if you want to prepare the material. When we ordering the material, one ship, you can show both end negative and positive cutting, and it's really easy to prepare the shaft and the plate. And couple examples say, when we're doing the alternation and the drawing, we actually come up with the Cardinal automatic. So, but actually, we need to do the numbering first. So I made some mistake at the beginning. I forgot to do the numbering, and then that would be a problem. But later on, if we read about the numbering rules, you make the rules, and then it's quite good because every time you change your drawing and change your model, all the drawing dimension in the drawing is just changed, and with the cow line. That's one thing, and at the later part, I'm a little bit slowing down to discuss or the sharing about the connection, because that is a really, really difficult things and costs us a lot of time. The value for this walkthrough is you make the stick model, we call the stick model, or the shaft model in Revit or in the Medas Sharp 2000, and all the loading and all the information is within that analyst model. But which part you can going to make the connection? We do the connection in advanced deal, and then it can come back to the Revit, and we have a lot of the plug-in. It's just connect to the Revit. So we make the whole thing smoothly. Oops. So for example, you can see when we're doing the Revit model, we can do some really simple connection and export to the advanced deal, and it will automatically to have upset, modify, delete, etc. And if we come back, this is advanced deal. They have a synchronized option to say import, export, or synchronize with the Revit. And then all this connection you done in the CAD, you can come back to the Revit. You can do the numbering, control, everything. And then come back to the Revit, you can do the multi-professional coordination. Especially say if you coordinate with the MEP or the architectural, and then it may request you to change the connection again. So we do not do the connection in Revit. We do the connection modeling in advanced deal, and then we come back to the Revit until that certain part becomes smoothly. We export that to the Navisworks, and then for the final presentation and the crash detection, etc. So this is the one part for that. So it's really changing the modeling method. For example, you can see if we're making a stair, we are not drawing it, because in advanced deal we have a lot of the connection mode. The connection mode, you can customize it if you know the C# or the C++. Otherwise, you have to select that and explore it. If you explore it, you can make your modification. So actually, at this moment, if you want to make a lot of the connection, it's not a really time-consuming. And previously, when the designer, they prepare the drawing, because the connection is too time-consuming, so we try to say using couple typical connection to express our design idea. But at this moment, we might say, well, why we not select some extremely example and just do the connection, put that in, because once we done the model, we finish this LOD 350 model, and we can just pass to the fabrication side. And the fabrication side, they just can run the numbering, and then do the shop drawing, prepare the shaft and see file. So that's the concept we apply in the Guilin airport terminals. And we also can export that to the Navisworks, no problem. You can see even if in the Navisworks it runs smoothly, not really heavy like that in a Revit, and all the playwork, all the nuns, and all the share start, you can really easily see that, and also you can see all the play triangularly, you can show that. And that's one thing. We just import it. Yeah, you can see. Once the whole model to the export to the advanced deal, the speed will become up just like at least couple seconds fast, right? And we also can export the advanced deal model to the BIM 360, but in China mainland, they are not really likely to using the public cloud. They're using some private cloud, something like that. But similarly, if you export that to the BIM 360, all the bolt and nuts is there. Nothing missing or suddenly disappear. And the drawing, you can using the BIM 360 to investigate or select or the drawing is with the model together. Wow. And so at this moment in Australia and in American, we try to say, even in China, they have a concept to say EPC, all right, or the design and build in Hong Kong. So we try to say, why not? Why not when we're doing the structural steel design, we put the connection in, because that is called the model, the BIM model 300. And then we put more connection in. We can think about the installation, the separation, and that will help to eliminate the design change. And it requests the detailer to engineer to work together, definitely. But what's the platform? I think the CAD, CAD, plug in with the advanced steel will be a good choice. That's one thing. And the second thing is AutoCAD done something good, something bad. For example, say if we using the robot, they actually have a function. Say in the robot, if we're using the robot to do the structural analysis design, once we finish the finished design, you can see all the connection point. We will have a little bit flat here. Actually, what happened is we have all the loading data in here. All right. So if we're using the robot, all this information, not only the 3D shape, not only the solid shape, we also with the statistic, all this loading, stress, all this data can go through, export to the advanced steel. So at this moment, if this project is not in China mainland, if this is the airport in the Europe, we actually can using the advanced steel to do the code checking, because they have EC3 Eurocode and the ASIC, the American code. So for example, say you see, we have a table here. If we're using the robot, in this table, if we click that, they will just automatically to load all this data. And then we can just run the checking, and it will have a report. And then this just like a connection report to say, well, if the bolt and nut and the plate, they have a significant match the EC3 or the ASIC. So this is one thing. And this is another thing is quite interesting. In London, a former CEO from the Arab, he built up a company and do a link. His company have a software called IDEA. This link, this plug-in with the advanced steel can do a little bit amazing things. For example, say, sometimes the engineer don't want to use in the robot. I like Shop 2000. I like the ETABS. All right. So what's going on? If we done the model by the advanced steel or the CAD, you can just select it. Once you select these things, you can see we can select the member first, and then we select the part first, and you do not need to do any double time modeling, and all this information will come up to their platform, and the 3D model is there. And you can put in the manually type in the data, or copy paste from the Excel, or in the ETABS, they already have the force, the loading for you, and then you just put it in, and then you can do the partially fitness analysis for this particular connection, and then come back the result. If all right, no problem, passed. Otherwise, you compare to the advanced CAD, and you change your number of the nuns, change your setting of the welding, change the thickness of the end plate, or even change the cross section for your UB, etc. All right, and then you do the testing again until that connection is passed, and then you can see this is what we call the BIM for the structural steel. And that helped us a lot in the Guilin airport, because you see, every time we discuss with the designer, the other engineer, to say, you do not give me this detail and that. And what happened is we come up with propose. We're telling you we have to stop, we have to separate, split the column, and we need to end some straw, and we need to do tie beam, secondary beam. And then they just ask, well, could you give me the design data? Could you give me some calculation book, etc.? Well, that helping us. And then they sign it and approve it, and then we can keep going to do the model. So we call that VDC walkthrough, virtual design construction. In the past 20 years, for the structural steel, they just start from the primitive design drawing, and keep loading. Every time you do the shop drawing, you have to come back. The us engineer, we spend a lot of time, but at this moment, we try to say combine the walkthrough, and you need the engineer to work harder and detailer to get involved, and then make this walkthrough come up more smoothly. So this project we just done about 4 months, and just roughly finished the roof, and later on we will keep in the 2017 we keep doing it and until the build up. So this is a project I share with all your friends, and thank you.